Good evening, everyone, at least in the Netherlands, and good day, good morning to all our international viewers. This might come as a bit of a surprise to see me as your host this evening for Azure Thursday. Well, it kind of was a surprise to me as well, to be honest, because I kind of still miss my partner in crime. But that definitely doesn't stop us to offer you some really cool content this evening. So, guess this is me introducing myself. So, my name is Esther Bartel, and instead of being announced, I'll probably be the one making the announcement myself. So, I joined the Azure Thursday team as one of their hosts, and happy to spread even more Azure fun and share more Azure fun with you all. So tonight we have two presenters that are gonna be focusing on IoT. And I don't know about you guys, but for me, IoT still kind of is my home automation projects. So I'm really looking forward to get educated and to discover a whole new world of possibilities and to become even more creative. So without much further ado, I guess it's time to introduce you to our first speaker of the evening. So I would like to welcome Sarah Maston. And hopefully, hi, at least we have our speakers present. That's a good start, definitely. So, and I am seeing that Sjoukje is jumping on board as well. So she will probably be right with us and lift that mysterious black screen that we're seeing right now. Sarah, I hope I pronounce your name correctly because, well, I did try to prepare very well today. And I did some research on LinkedIn, and I noticed that you're not just a senior solution architect at Microsoft. You're not just one of the founders of Project 15, which I'm pretty sure you're going to tell us all about in the next 45 minutes. But I also noticed that you started even earlier on with promoting IoT and finding creative solutions, and even getting awarded for it by Microsoft when you basically invented Project Edison. So can you perhaps share a little bit about that?
We cannot hear you.
Yes, I was going to say. So this is the, I'm sorry, your mute bingo that we're doing right now.
What a start, Esther, with your first hosting session. I'm too late. Sarah is on mute.
I already announced my introduction or joining Azure Thursday. So yeah. I think we're all good to go. Except for maybe finding some way to make sure that we unmute Sarah.
Yes, maybe Henk can help us with that.
Yes.
Oh, Sarah has a solution.
No.
No? Maybe it helps, Sarah, if you rejoin the call again?
This is the moment where IoT is going to save us. Not yet.
No.
And maybe this is the moment where I am at least realizing, Sjoukje, that that dance that we discussed earlier might just need to happen.
Yeah. We should definitely rehearse something. If we, yes.
We have... Ta-da! Technology saves us again. Thank you.
All right. So Hi, yes, Project Edison. Actually, Project Edison led to Project 15. I'm going to talk about that today.
Awesome.
Yeah,
Great.
but I'm
Then,
so happy to be here, even though I don't know how to use my computer, obviously. It's
no,
fine.
no worries. No worries.
No worries.
So,
We're kind of enjoying the to make it spontaneous and a bit chaotic sometimes, because I guess that adds to the fun that we're having these evenings. So
It's live TV. This is what live TV is about, or live web TV.
yes,
yeah,
and I guess it is a day in our lives in these times still, trying to get people to feel invited into our virtual homes. So I guess with every home there might be some hiccups on the line and along the way. But so then I'm not going to ask you to explain Project Edison because you obviously already have some planned in the presentation.
Ooh.
But I did notice that you have been a very strong advocate of IoT and not just, well, as I explained to the audience previously, for me, IoT still is kind of stuck in my home automation challenges. But what I love about, and I'm sure you're going to dive into that in just a minute, but what I love about the way you look at IoT is that it's a very creative way of finding commercial solutions that are out there and find new ways to incorporate them and to help not just commercial other new projects, but also a more humane usage of IoT. So
Yeah, I mean, IoT really opens the door for all of us to reinvent, solutions in a super different way. The sense of you're thinking about retail, especially in our situation that we're in with the pandemic. Now we have all these
mhm.
incredibly touchless systems and sensors and everything. So even thinking differently, it really opens the door to think differently, even on more traditional use cases that we're used to. I feel.
Yeah, I'm really interested to definitely hear you more, speak more, and present more on IoT and the way you incorporate that, especially in Project 15. So I guess even though I still have a couple of questions, I'm gonna let you start with the presentation, Sarah, and then afterwards we'll come back and I'll also make sure that I keep an eye out on any questions that might occur during the presentation and get back to you for some Q&A at the end.
Okay, great. I think Hank was going to roll a video before I.
We lose one elephant from the planet every 15 minutes. We will lose all elephants in 10 years. It is that statistic that pushed me into action. 15 minutes. The issues we're having around preservation, nature, and what I've learned is that scientists need help and they're running out of time. Project 15 is about building this bridge between the scientific community and the technical community so they can learn what tools we can bring to the table.
The Serengeti is one of the largest parks in Africa at 17,000 square kilometers, yet the Serengeti only has 150 guards. Imagine trying to protect the state of Maryland with 150 rangers. It's impossible. We started on TrailGuard about 4 years ago. It's a sensor put out in the field that can detect poachers and stop them before they kill. The first ones were successful. The problem was that our camera system sent every image, and that drained the battery really fast.
By listening to him, I learned that a solution that I had designed applied, and that was a safety platform called Project Edison. His camera sent events. It was the same as anything we did in a city, and that was my aha moment.
Sarah talks about the idea and I said, I know how to do it.
We started drawing boundaries and where we could put devices and how that could all be brought up to the cloud for better notification of rangers.
We built Azure as a hyperscale cloud services platform. We're able to provide machine learning, analytics, or reporting all over the world.
Microsoft is really advancing these deep neural network models that are able to identify any species that is of concern to conservation.
We have a truly hybrid platform. I can run the same services that I have in the cloud down at the edge.
Microsoft's been dedicated to environmental sustainability for a long time. We have this culture that says if you can invent a technology solution to that problem, you should do that.
Project 15 can really have a bigger impact with something I already know.
There's a breadth of challenges that need to be solved. There's connectivity, networking, there's devices to be built.
One idea is to use the drone and the AI, and with this solar cells, we can cover big parks in Africa with the self-charging drones.
These are the kind of ideas. There's animal preservation, climate research, water purification.
We are looking for contribution from people with different technologies, skills, experience. Everybody can contribute.
Whatever you are interested in, take 15 minutes just to think about it.
How can the solutions you're developing be reimagined in the pursuit of solving some of the world's most critical challenges? Join Project 15 and bring your ideas to the table.
Please join us.
Join us.
Join us.
Please join us.
All right.
I think I don't know if
Echo.
Let me
Let me
know.
know.
Yes, no.
I've been muted. All right. So can you still hear me? Yes? Okay. I'll just keep talking until somebody tells me they can't hear me, which is fine. Today's show is a little bit about technical difficulties, but it's also about how do we use IoT to solve technical difficulties when it comes to preservation. So I wanted to give you the origin story of how Project 15 came to be. And I hinted at it in the opening that I was going to talk a little bit about Project Edison. But a little about me. So I'm Sarah Maston. I'm a senior IoT solution architect here at Microsoft. I live near headquarters. So for me, it's early. I know for you, it's in the evening. I'm really, really thrilled to be here today. My hobbies include chasing my 9-year-old around, and you might see him run by because we're doing homeschooling. And I love to build Legos, and I have been keeping up on my science fiction reading, especially because I haven't traveled for the past year. My specialty is process architecture and data architecture, and I've been doing that for about 20 years, give or take. So this is Thomas, and her name was Thomas, who is a girl. And this was my cat, and she looks a little cranky. Not a lot of people know that you got Project 15. It went from cats to elephants, but how did that happen? So what happened is that there was, I lived in this building in Redmond, Washington, which is on the west coast of the United States. And I lived on the top floor. And one day I was just standing outside and I saw a whole bunch of smoke, just so much smoke. And I freaked out and I ran into the building to go save my cat. The alarm bell had not gone off yet. And, I ran upstairs. I threw the cat into the cat carrier. We ran back downstairs. It was pretty frightening and confusing. And then the bell went off. And I was standing outside, and then the fire folks came, and they said, "Oh, everything's fine. Everybody go back in." And the next day, I saw the gentleman that runs the building. And I said, hey, what was that about? Because I've never seen so much smoke. And he said, I don't know why. I don't know why. I mean, that fire was out for 20 minutes before your bells went off. And I went, what? And then he said, and by the way, that fire was as far away from you as possible. It was on the other side of the campus. And I went, I'm sorry, I don't understand. And then he goes, oh, I know what happened. They put up a fan and it blew the smoke because underneath my buildings was a garage level where all the cars were parked. And it had moved across the bottom level, and that's what I saw. And I kind of, jumped up and down a little bit and said, oh my God, there has to be a better way to talk to people within an emergency. Because if only there was an app or some sort of sensor that could have told me that. And what happened was I went to work the next day and I drew something, and it became Project Edison. And what it was, and this is the proof of concept story with which I got the idea funded to be built with a partner of ours, was that if you could just use a simple light bulb, and imagine this is Microsoft's campus. Microsoft's campus is very large. It's the size of a town. There's 120 buildings or something, which is very, very large. And if you just put a geocoded light bulb or use, a bracelet, that you're wearing, that if something happened on your campus, you would be within this radius of awareness. And what it meant was if the light bulb turned yellow or your bracelet vibrated to let you know that something was happening, that you wouldn't panic. You would know that you were not in immediate danger. And therefore, when the notifications came in, whether it's Twitter or something else, there would be much less confusion if you knew that you were actually safe and now you had to go get instructions to go do something. And of course, if something happened closer to you, a sensor would turn the light bulb red, you'd get a different kind of vibration, and you'd say, ooh, I have to get out of here. And so this concept of using IoT to communicate in an emergency was actually used. We had put it out on GitHub with our partner, and that partner took that idea and they created a safety solution for schools. And April of 2019, the Houston School District, one of the school districts there, was using it to make a safe school using communication in this way. And that was incredibly exciting. And at the same time, I met a gentleman whose name was Eric, who you saw in the video. Dr. Dinerstein is one of the world's leading conservationists. He's fascinating. He's also an author. And, if you're interested, it's his career is really, really interesting to go and look at. But what he's done recently is he invented this TrailGuard AI solution. He's at a nonprofit organization called Resolve. And this solution, he won a grant from the Leonardo DiCaprio Foundation and with Microsoft's AI for Earth to build out this idea of making a really smart camera trap to catch poachers before they can kill. And so I met Eric and we started talking, and he was mentoring me on all of these use cases. And Daisuke, who is in the video, who wound up to be my co-founder of this and the first person I asked to join me, I drew this picture, and this was the first napkin drawing, if you will, of what conservation looked like to me. And to me, it was a population that can't defend itself. It was a place where they live, and you're trying to stop someone or something or make them less impactful using sensors. And then you're trying to communicate to people that can get help. And in the case of the park, it is the rangers. And what was so interesting about this to me is that this was just another use case like Project Edison. And I thought, well, what else can the commercial solutioning world, people like me, do to help? Because until that moment, I had watched the Earth in decline. I've been on the Earth almost 50 years. I'm a little younger than Earth Day, which is, I think, 51 years old, this last April. But, I never felt like I could really do anything. And so for this one moment, I went, whoa, okay, maybe we can help. Because if you start to think about this, if you're applying what was Project Edison into anti-poaching, well, what is the real difference between shoplifting or stealing a shirt from a big store and then stealing a pangolin from a park? At its essence, there's no real difference between these use cases, just challenges to solve. And so we put up that video with the support of our group and our marketing, and that video went out in October of 2019. We put up this webpage. This webpage no longer is up, so this is what it looked like, and it pretty much just said, hey, if you'd like to come find out if we can help, are you a scientist? Are you a technologist? And then we asked a few questions about what you did and try. That was our first attempt to really build sort of the friends of Project 15. And this was a type of phone in our eyes. And we kind of sat and waited to see if anyone would call. So about 3 months later, we got the first call in the form of an email. And it was from a company called Zambezi Partners. And this was an interesting startup that was building a solution for conservation to protect an elephant corridor. And although they were working with device partners and they were working with scientists on the data science side, they really didn't know much about building that in-between IoT platform. And so, okay, that's interesting. All right, I think we can help you. And then the second call came in, and this was from an organization called the Red Panda Network. The Red Panda Network is another interesting organization. I had never heard of them, and then once I started looking, I was like, "Oh, these are very cute." Red pandas are adorable. They are not related to giant pandas, by the way, and they were discovered, I believe, 50 years. Don't quote me, but I think 50 years before giant pandas were discovered. So we met with them, and then the third call came. And the third call came from a woman named Yoko Watanabe. And Yoko ran a group in the United Nations Development Program called the Small Grants Program, the GEF Small Grants Program, which is implemented by the United Nations Development Program. And she operated in 125 countries. This is another organization that I, to be honest, had not heard of. And once I started learning about them, and they're fascinating and they do such important work around the world. And she thought, well, we're interested to know if you can bring this type of thinking about how to apply your commercial processes of solutioning into this space with us. And at this point, when we were working with Zambezi and we were working with Red Panda, that's two projects, and Daisuke and I spend our nighttime and weekend hours working on it. It's truly a passion project. But when we met Yoko and her team, she has thousands of projects. And so now we suddenly had to start thinking about, well, how are we going to scale? Because that's kind of a scale problem. And they gave us 3 projects to start with from the Small Grants Program. And so now we had 5 projects, and I started taking notes about how do scientific projects stall? Why do they stall? What are their roadblocks? And so this is the catch-22, and that's a term, I don't know if you're familiar with it, so I'll explain it. A catch-22 is when you have, it's a catch-22. I want to go to the store, but then I don't know how to go to the store, but I'd like to go to the store. It's actually named after a book, if you want to read it. So the catch-22 was, I know what to do with the data, and I can get the grant to work with the data, but I don't know how to get the data. And so, how do I get that new data from camera traps, etc.? And that's an IoT problem, not a data science problem. Proof of concepts. I know how to build, it's another type of catch-22, but I know how to build a device, but I don't know how to build a holistic cloud solution. Number 3 that I started to notice was small fish. So this means, maybe it's someone who's a bit younger and has an idea, but doesn't have the agency or know where to go with the idea yet. Maybe it's somebody who didn't go to college and is not an academic, and they perhaps feel that the grants aren't for them because maybe they're attached to PhDs or something like that. Here's the original spirit of Project 15 was the pit of financial despair. So this was, when we came out with the video, I really felt that grant money might be wasted if you're trying to reinvent something that exists already, and we just don't know each other yet. So that was the pit of financial despair. And then we have showcase. Maybe you've partnered with somebody and then you did something for an event, but then it didn't go anywhere or it stalled out after that. And then scaling out a solution. Now there is a slide at Microsoft somewhere in my commercial world, which pretty much has all of these things as reasons that every solution can stall. So there wasn't much of a difference between our commercial solutioning world and the scientific developer solutioning world. So the next idea that I remember talking to Daisuke, I said, well, what if, this is a big what if project, honestly. What if we created 80% of this solution and put it on GitHub? Because we kept drawing the same architectures, and that's what I do in my day job. Is I come in and I help partners. What does that architecture look like on Azure? Well, here's what it looks like, and that same set of services was always the same. And we learned that people did not want to. They didn't have time to learn all those bits and pieces. They just needed to get going, and we're out of time. So why not? It takes Daisuke and me days to put something like that together, and then it's faster to learn it. So that's what we did, and our goals were that we could kind of jump the skill gap, because that's how you learn. You find out how to do something, you have a challenge at work, and then you go figure out how to do it. Your first time you're solutioning, it's not exactly glamorous, it's not pretty. I did this with data warehousing back in the day. I just needed to learn how to do that fact table. The next one I did was prettier, but really get them going and boost the timeline. And then we are running out of time. And so something that's simple for me to do, for Daisuke to do, for you to do, that's hard for other people. And we mustn't forget that. Like, we have skills that are really important and can contribute. And then we don't want this to fail, because it's expensive to get an IoT specialist. But if you have a lot of it done, then you open the door to maybe a generalist developer, someone who's learning IoT. You want to just make a nice UI on top of it. You want to just connect a device. There's much less, and it opens the door for many, many more people to either get involved with IoT or just expand on it. And it also opened it up to the open source community and developers and universities to be able to use this. So this is what it looked like. This is the high level. If you go out to our GitHub page, you'll see this picture and many, many others. But this one is, the light green boxes on here, they just come with it. You're going to spin it up and you get it. The darker green, these are things that are going to need a little more customization. And then these blue boxes, that is your 10 to 20%, that really differentiates your solution from any other IoT solution out there. Because if you're familiar with building IoT solutions, the plumbing that we put in there is very similar but it's really just when you start doing business logic, when you're, what actions am I taking from this data? That's where it starts to get unique. And so this is the more technical architecture of it, reference architecture. And it's coming in through IoT Hub. This is all the usual suspects, especially if you've been developing on Azure IoT. And the parts in red are those that can be added on. And we use this as an example as we talk to our scientific developer friends now that we have for Project 15. Now, one thing to mention, and maybe in the future, Daisuke can come visit your event here and meet you all, because this spins up in under 10 minutes. And so once you click deploy to Azure, it'll set it up in your tenant, and we've written instructions that are hopefully helpful if somebody's just beginning, and for anyone more experienced, you're just like, okay, done. So the next thing was partnering for scale. So we, as I mentioned, as the projects were coming in, we had to start thinking about, okay, well, how else are we going to, growth hack these solutions and scale them? So we have a Microsoft Capstone program that is run by a colleague of mine. His name is Lee Stott. And I was talking to him. I said, hey, what if we could partner the students that are doing their senior capstones, their thesis work at universities with NGO nonprofits, and then they move these projects along further. And he said, well, that sounds like a good idea. Let's do that. So I'm excited to say that recently we've announced the results of the first batch of capstone projects that came out. And I'm going to highlight one of them today. And this is with the UCL, stands for University College London. So I mentioned the Red Panda Network in the beginning. So this was the process architecture summary for what was going on there. It was a very manual process. You walked up into the Himalayas, you collected data, you took observations, you wrote them down on pen and paper. They had some first generation camera traps. And then it took months to get results for Sonam, who runs that organization. Now, what Farid, who was the student who worked with the Red Panda Network on his capstone, did is he took all of that and he created this, what I think is beautiful UI application that incorporates custom vision. And now the images can be uploaded automatically. They, tagged Panda, not Panda, and all of that is available out on GitHub if you'd like to go explore it. I put the link down at the bottom here. It's pretty phenomenal. And one thing that he did, which I think is really interesting, is he turned any smartphone camera into a camera trap by using the metadata and then putting it on a map. So if you have different use cases, you can use his work to help your solutioning. It's pretty good stuff there. Oh, there he is. Look how cute he is. I'm a big fan of the Red Panda. There's only 2,500 of them left in the wild. That's one thing that I've learned since starting this project 2 years ago is, there are incredible people out there building solutions for our planet. And, there are sad facts as well, but there's a lot of hope in this solutioning community. So if you're interested or you're going to go volunteer or work on something with an organization you like, I think you'll have a good time with all that you're going to learn. It's really, really cool, actually. So the next idea, because capstones are, pretty high touch, they took about 3 months each. And we came up with this idea around, well, could we just talk to a nonprofit and get their data and some use cases they need help solving and see what happens? Why not? So the next what if, we partnered with, let me get my slides to work. We partnered with the University of Oxford and their AI class for their continuing education. And I reached out to the well, I already told you what it was. These slides are out of order. So I reached out to the Elephant Listening Project And this is a fascinating organization that does what it looks like it does. It listens to elephants. They are based in Cornell University, which is in New York in the United States. And they pretty much put out listening devices. And what's interesting about elephants is that they speak in a frequency that we cannot hear. So biological males and biological females, our ears, depending on which ears you have, you cannot hear them. They speak in something called infrasound, and it was discovered about 30 years ago by, I believe, by Dr. Joyce Poole. And these, you see these echoes here? That's an echo from the reverberation of their rumbles. And so I've learned a lot about infrasound in the last few months. I'm by no means an expert in it, but if you're interested in that and you're doing other, sound-based research or projects, this could be really interesting to you. And something that happened in that class is, we posed the question and said, here is a project, here are some use cases. They have never been able to count the elephants in a data segment here. They have been able to say if it's one elephant, and they have been able to say it is 2 or more elephants. And so I'm happy to share, and I can share some links after this talk if you're interested, that one of the student groups at Oxford found a way to automatically count elephants for the first time and put it out on open source. So for the section of the scientific community that's researching that, they now have that available to them to help them with their work. Okay, I have no idea how I'm doing on time because I wasn't really paying attention to time because I'm bad with time. That's another weird fact. It's not on LinkedIn. I'm terrible with time. But I'm going to talk about graphs a little bit. So graphs, I don't know how many of you, if we were live, I would say, raise your hand if you like graphs. I love graphs. To be fully transparent. I think graphs are super interesting. From a data perspective, the first part of my career was very much in relational data. And then of course it matured into dimensional, and, then you've got columnar databases, all the things about data. If you come from a background like mine, as you know, databases didn't really change until the apps, the rise of the apps, and big data 1.0 showed up, and suddenly there was like every different kind of awesome weird database was being invented to deal with how much data we were producing. Graphs are, social graphs. I put this here because they are the most well-known, especially if you're not coming from a data background, but Facebook, LinkedIn, many of these apps that we use for social media would not be possible without graphs, because graphs are a relationship first data structure. So you can, if you're using relational databases or RDBMS type databases, when you get too many joins, you fall over. And that was a huge problem. And when you start getting into, advanced analytics, the ability to start querying relationships is really interesting, because with this structure, you can say, what's my 4th degree friend who likes to listen to the Smiths, and then you get a list. And recommendation engines are based on graphs, for shopping, hey, you bought this 16 years ago and we got a record of it, and now we'd like to sell you this. Isn't that exciting? Those recommendation engines are based on graph technology. This is another type of graph. In a past life, I invented a graph for nutrition when I was at IBM. And I just put this in here as an example besides social graphs, because this is the beat. And the nutrition graph was to connect food by phytochemicals in the food to reactions in your body to diseases and fighting diseases. So that's something that in a relational model, and I know I spent 12 years inventing that, that falls over. But graphs really open up the ability to do really weird and interesting things. all of this is to lead up to the fact that Azure Digital Twins is now graph-based. And this is really, really interesting. And I don't know how many of you, I would, again, show of hands, who is playing with this. So this is interesting. And let me tell you why I think this is interesting. So I have a thought exercise, and I'm going to close out with this. And 2 years ago, when I started talking to people about conservation, I realized there's two sides to conservation. There's the park side, where, things, what Eric is doing with camera traps. There's other organizations like Smart Parks, and, they're doing smart collars and things like that, drones. That's all to manage the safety of the animals and the people that work on the park side. Now, on the other side, there's a very, serious and sad side, as we know. And I'm going to talk about it a little bit, because once the animal has been poached at the airports and at the shipping container place, the ports, when they find remains, there is a whole nother group of scientists where they work to figure out where those remains came from, which elephant family was affected by this crime, etc. And these are the justice side systems, and this is where you have great organizations working to figure that side out. But in the middle, there's a huge gap, and it's in this gap where all the bad guys get away. And so I have a colleague, and his name's Kirk Arthur, and he's one of the leaders of our public safety, government, and justice side of the Microsoft house. And in the beginning of the project, I met with him. I had lunch, and I said, I don't know anything about catching bad guys, but you do. And so, I started to learn about this side of conservation. And I met another scientist whose name was Dr. Wasser, and he works at University of Washington, and he does a lot of genetic analysis to trace back where these things came from. And so I started drawing something. So on the park side, if you look at this in a very simple graph representation, you have an elephant who has a collar, who has a movement sensor, and then a fall down alarm, and then it sends a message. This is very typical transactional IoT. The sensor feels something, and then it tells you something, and then you do something. Things, insights, actions, right? So if you kind of expand out a little bit and you say, all right, well, now I'm going to put on a graph. I have a park. My park has a fence. My fence has a camera. My camera can detect object detection of a human. The poacher is walking, doing an action. The camera picks it up. It sends an alert, and you have a system that knows what to do with that. That's very traditional IoT. ML down here on the camera, etc. You have your elephant again. I have a fall down alarm, my collar, and now I have two messages. And what's interesting about this is that there's another variable that's not recorded, but it will be recorded by the devices, which is time. And so now when you know that I saw a human and then this elephant fell down, was there enough time that seems like a poaching event? And that's what we do every day, all of us, right? And so, and there's one other thing I just want to put out there for your thinking, is something that I conceptualized as very nuanced and unique to these types of solutions, is that when we build IoT solutions that talk to machines, it is very easy to tell a machine, well, easy is oversimplifying, but for the sake of argument, it is easier to tell a machine to stop doing something if it's vibrating and we pick it up on a sensor. But the elephant has to do something on its being, on its living creature side of electricity, to send this alert. And so that it is already more complex because of that fact. And you can't really talk back to the elephant and say, hey there, please go run over there. Like, it's just not a thing. So that's something to keep in mind of why these are such complex use cases when you start to think about them. Then we've got this process over here. So I added this to the graph. So we have a shipping container, and maybe there's a device that can smell something. It smells material, and it sends an alarm, and we get the message. And then we have a platform that tells us, right? Same IoT. But if we have these together in one system, and I put this little note here, if we were able to get the DNA of the elephant, the scientists can now work faster to figure out what was going on. And so this is just how sustainability and conservation would work on a graph as a thought exercise. So I wrote a longer article about this that I put on LinkedIn. If you're interested, I can share that. So that's really, really interesting to me. And something to know about the Project 15 open platform is that when you click deploy to Azure, we Azure Digital Twins enabled it a couple months ago. And so you actually just pick a true or false if you want the Digital Twins version versus the IoT PaaS, version without Digital Twins. So that's Project 15, plus a little bit about graph theory thought exercises. If you want to learn more, I've put the links. The Project 15 code link goes right out to our GitHub. It's written, and I love feedback, so if you have any feedback, send it to us. It's written so that if you're new to IoT and you're coming in possibly as a specialist from another specialty, you can come in, get an idea of what this is, and then as you click on deploy and the development guide, it gets more and more specific. It of course has links out to the MS Learn documentation. We have so much cool enablement stuff to get you going on Azure IoT. So we just made it as kind of a top level guide on where to go from here to try to help accelerate these solutions. I'm on Twitter, I'm on LinkedIn, reach out. And that is Project 15.
Wow, that was an amazing story, Sarah. And you already got me so excited about how you're using IoT. I do have a couple of questions, though, because even though I'm still baffled by the simplicity that you used with the graph to explain all the relationships between the different actions and how you can respond to the situations. So the first question that popped up in my head was a bit focused on context awareness, because how are you going to anticipate the fact that a lot of poachers are becoming smarter and becoming tech savvy as well, and starting to learn to use drones for their own use to track the animals and to well, I'm not going to say find smarter ways to track them down, because I don't want to give them any ideas, but I think you understand where I'm going with my question. How are we going to anticipate on them evolving?
So there are incredible, so cybersecurity is not my specialty. That's why, I have very smart friends like Kirk, and I've met such incredible people that are working on the justice side. There are such cool security firms for IoT that not only, they're not just doing people stuff, they're doing any kind of stuff. And so if that's an area you're interested in, absolutely. They write papers, of course, in this area. If you do get into this area, it is important to protect, what you're doing, etc. So, none of the camera traps that were on the map for the red panda, those are all fake. Those don't exist there on that map exactly. But it's the same kind of security that we need to do for any of us. It's why, I know this isn't an Azure Sphere talk, but it's why, Azure Sphere as an option for IoT security is a really good option, because we all need that safety from any kind of cyber type criminal. And that, yes. So my short answer is yes. And my longer answer is if you start to explore like the companies doing that with IoT and security, it's fascinating, especially if you're into that.
Okay, that makes sense. And I'll definitely start diving into that. Another thing that I remember from my Azure Fundamentals training and course is that, well, at least thinking of Africa, I do know that from a networking perspective, communications can be less trustful. So how do you deal with the fact that some of the data might not come across immediately? Or is there a mechanism within the solution, or maybe already built into Azure, that helps you to make sure that if there's any latency or any fallout in the network, that you still are able to retrieve the data that is cached or something like that?
Okay. So that is I mean, it's interesting because those latency issues, data, when the packets arrive, do all of those things. That's the same. We have those in industrial solutions. We have these problems if you're building a solution for a mine. Like, how do you talk to the people down in the mine, in the earth? How do you do the route, etc. LoRaWAN, is often talked about when you start talking about long distance and getting things in a vast area. Same thing. So if you're working on those types of solutions, that's what's interesting of coming in and helping, because that is an issue. One other thing to mention is that a lot of this is done on the edge, because you're working in areas that are so remote that you need to be doing that intelligence on the edge, and you need to be thinking of smart ways, because if you were going to share up every single picture through a satellite connection, I mean, it's expensive. And so this is really, it's sort of one of those things where they throw a limited set of tools on the table, and then we as technologists have to say, okay, how can we fix this? And so the answer is, again, yes. And there's like a bunch of ways to flip that Rubik's Cube to try to figure that out.
Well, thank you for giving me not just a short answer, but also a longer explanation, because my head is still trying to get all that data processed, and I might just need a little bit longer. One final question.
Maybe you should do that on your edge, Esther. Process it on the edge. Yeah.
Yes. I was wondering if there was a nice joke in there, but thanks for that. No, I just have one final question, because I personally am very interested in Project 15. But do you see that a lot of different countries, because your example, of course, is very focused on poachers, and Africa is a great example for that. But do you see a lot of different continents and countries developing a strong interest in Project 15 too?
So what's interesting is that, especially, and I'll, when I write about this, it expands into IoT is just in the middle of sustainability, because when you think about smart energy, you think about smart water, you think about smart waste, all of these solutions we've been doing. I have a sort of a quote that says, "Smart city is a sustainable city." And when we are trying to reduce, energy bills, that's the immediate ROI on a solution that's smart energy. I have less money paid because my lights turn off and they're smart. But the reality is that that's leading to less consumption, which is leading to less of a footprint. And so, I use the original, example of Project 15 is conservation. But once you see that IoT is really, really in the middle of all of our sustainability efforts, it doesn't matter what kind of sensor you're attaching and what you're going to do with that 20% of your use case. Like, So yes, I'm hopeful. We've been working with different types of projects through the GEF Small Grants Program, where it's urban sustainability or smart oceans or land. So really, it's just such a big topic that it helps to just tell the use case of a smaller and then bring it into the bigger IoT driving sustainability story, like you're talking about.
Awesome. So thank you so very much for presenting and for educating us and encouraging me to understand that even a small change and a small adaptation of IoT can already help in basically the footprint that I have and the contributions that I can do to help for a sustainable world. So thank you for that.
Yeah, thank you, Sarah. Such an incredible project, and I'm definitely going to check it out and see if I can contribute to it. Thanks.
Awesome. Thank you.
And we're back with our next speaker, another IoT session, and this time from Sumner van der Velde. Welcome, Sumner.
Yes, hello. Hello, can you hear me?
Yes, we can hear you.
Oh, very good. Hello,
Check.
Esther. Hello, Sjoukje.
Hi, Sumner. And how are you, Sumner?
I'm fine. I'm doing the stuff that I really, really like, and that's Internet of Things, IoT. So
Yeah.
I'm a happy man.
Yeah, and what are you working on? Can you give us some examples?
Well, it's also a little bit part of the presentation, but I can give some stuff away already. I am mainly doing IoT on the edge. So that's on the edge of a local network, and it's mostly in factories. So machines connecting telemetry from that machine to the cloud. And that way we try to get some insights in how the machines are performing, and maybe they can be optimized. And that goes in a wide variety of solutions. All around the world, on ships or in factories in different parts of the world, or even in the jungle, which I will show a little bit later on.
Sounds exciting. Okay,
So,
then we
yeah.
should hop over to your presentation, because I'm very curious right now. So you're going to
Okay.
talk about how you can solve those real-world problems using ML.NET and Azure IoT Edge, right?
At least the edge part, the ML's part, I tried to get a nice presentation, but well, it's about the physical world. We have to cope with real devices. So in the end, I had to skip the machine learning part because hardware was failing on me. But I have a really nice alternative, and that's a connected beer lift.
Okay,
So
sounds good.
You already won me over.
And beer, IoT and beer is a really good combination. So, and
Okay,
of
so
course,
then,
be responsible.
of course, yeah, Good remark. So then the floor is yours. Good luck with your session.
Okay, here we go. Yes, we will have a session about the internet connected beer lift. But first we look at IoT. Well, you have seen my face. It's a pretty old photo I now see because with Corona, okay, there's a beard now. But I'm an MVP in IoT, Azure IoT. And the stuff that I do is all about Internet of Things. And if we look at the definition of Internet of Things, we have to cope with telemetry data that comes from sensors, and that will be sent into a network, obviously the cloud. So we have on one side the physical world, the devices, and on the other hand we have the cloud. And our job is to bring those worlds together. And this is pretty new. The last, say, 5-6 years, Microsoft started in 2015 with IoT. And before that, you had to have a degree in electronics to get something connected. But nowadays, it's easy to start with IoT. First of all, hardware is cheap. A device like this one, I have an ESP for the camera. You can buy it in China, including shipping, for say $5, and that's incredible. And it is network internet connected. There's a Wi-Fi on there, so you need some kind of communication, and that can be, for example, Wi-Fi or a 4G communication or something with LoRa, which was already discussed. A device like this one, it's a temperature meter. It can last for 3-4 years in a outside world environment or in a factory. Those can be connected 5 kilometers, maybe even 10 kilometers if you're lucky. So connectivity is pervasive. It's there. Well, the only location where I have no internet is in my back garden, but okay. And then development. You don't have to be a programmer. School children, artists. Well, actually, everybody can start with IoT. If you're willing to open a browser and move some blocks of code, you can start developing an application for your device. And because it's not only a place, a solution that can be built by developers, by technical skilled people. We see a lot of new innovative scenarios. There are some strange solutions like a connected pet toilet or a connected couch or a connected umbrella. But those are not that common. What we see more is something like the part that's on the right side, your Nest thermostat to control the heating in your house, the lights, bulbs in your house that can be turned on and turned off even over the internet, or you have a smart meter. So on the left side, that's the place where makers are. They are using those little devices like this one, which are just a few dollars, and you're good to go. You can connect something to it. And on the other side, there's the market and the companies which are building more industrial solutions. And I'm in both worlds. I started on the left, but nowadays I'm mostly doing stuff on the right. And here are some examples of what I did. to the left, there's a really, really large device. It's built in IJmuiden in the Netherlands. And it is a smart heave. It's a hook which is put on a crane like on the picture, a very large crane. And it's designed to be used at sea. So there are waves, everything is moving, ships are moving. And if you want to tow some load, a very heavy load, for example, for those windmills, you have to compensate for that moving ship or the moving load. So this is just like the camera on top of a drone, which can compensate the movements of the drone. This is the same, but a little bit larger. And to the right, there's a project that I've done with some colleagues, and it's in the jungle of Malaysia. There's a factory in the jungle, and we were taking measurements from machines in that factory lot, and it's the rainforest. So you think humidity is a problem and temperature? Yes, that is. But it's a rainforest, so it rains a lot. That means also thunder and lightning. So we had to be very secure about not frying everything, all the hardware, when there was a lightning strike. So this was a really harsh condition. And let me show you. Here's a picture of the inside of the cabinet. And as you can see, there are some fans. It was to suck out the air of the cabinet, that white box, and therefore the humidity could be lower and the temperature could be lower. And it worked until people started to open the box and start to put in wires, and they left open the box without letting us. We were not in control. We were living in the Netherlands, and the box is in Malaysia. So, in the end, the fans were fried. The lower one is not working anymore, and the top one, it's not efficient anymore. So this is the physical world. So it's not only the data and the really nice cloud features and websites and stuff. We also have to think about that physical part. So it's quite a challenge, but it's fun. We have the physical parts, we have that connectivity, then we need a platform. And as in this picture, there is a platform available, for example, from Microsoft, and it's all about those three things: the things which are there in the world, and they generate data. That data is sent to the cloud, and we try to figure out what's happening, to get some insights, and from there, and that's the real functionality that we are looking for, that we are able to take action on top of those insights. And this is a picture. You can place it almost on top of each IoT platform. And the stuff that I'm doing right now mostly is on the edge part. So that's the last mile between the factory and the cloud, to connect devices to the cloud. And because once the data, when it comes into the cloud, we are good to go. That's a safe zone. That's something that we can do for 20 years already. Filling databases, showing websites, building mobile applications, machine learning, of course. But the hardest part, I think, and most fun part, is that stuff to the left. It's a challenge. So the devices have to be connected to the cloud. And for that, we use something that's called an Azure Iot Hub. It's a gateway, a cloud gateway, and it is capable of connecting thousands or maybe even up to 1 million devices. And each device has its own security. It has its own keys. It has its own identity. So one device cannot send data like impersonating another device. And also the communication between device and cloud is secure. It's secured by TLS, SSL. And the Iot Hub is also cloud hosted. So it's part of the Azure cloud. It's a platform as a service solution. So there's a lot of stuff going underneath the hoods. And we are not really interested in that part. We are just connecting devices, getting the telemetry, and from there we route it towards other services in the cloud. We can put it on an event hub or on a service bus, or we can put the messages on the event grid. And from there, insights can be taken from that raw telemetry that's coming in. And next to ingesting information, telemetry from the devices, it's also about supporting cloud to device communication. So there's a two-way communication. And last but not least, the messages coming in can also be enriched. So for example, if you have a message coming from a certain device, which is working at a certain location, and you know that location, you don't have to send that location information with the message to the cloud. So each message has that same location. No, you can just send the message. The Iot Hub will look up the location. That's something that you can program or configure. You can take the location which is registered with that device and put that into the message extra, and then it routes into the cloud. So for example, if a certain device is from a certain company, you can add the company name. So if we look at a more real-world IoT solution, a little bit like what Sarah has shown already, we see that Iot Hub there, and it's the data that is coming in, that is flowing into the cloud. It's sent towards logic apps, or it's used for web applications, or it can be used for AI. And the way to look at the data that's coming in is as looking at it as hot data, warm data, and cool data. And hot data, that is data which needs attention. There's an alert or an event or something happening, and you want to respond to it in seconds. That's the whole path. Send something towards a website or towards a notification hub to send an email or an alert over to your phone. On the other side, there's cool data. That's data that has no real meaning at this moment. It's raw data coming from the device, but at some point in time, there could be value in there. So you want to store it cheap, and it must still be queryable. So a data scientist can look at it and say, okay, I see some value in there, and I know how to get that value out of that. And there's only value in there for once an hour, an aggregation or a filter. And once you have that, that's called a warm path. So for example, if you want to have a chart with the information, a temperature with a average of each 5 minutes, yeah, then you can filter out a lot of data. You can take the average and maybe the minimum and maximum and standard deviation, whatever. And that is represented to a on a screen, and every few minutes somebody looks at that screen. That's the warm path. So that is something that we can do. If you're into programming, I don't think that what I've just told is a really new stuff. What about doing that same handling of the data also locally? If you want to, if you have a device which is quite powerful, for example, a Raspberry Pi, it's a cheap but really powerful device. You have some compute over there, so that could come in handy. And that's called the edge. It's on the edge of the local network. And why not combine that? Why not do both cloud and edge? If you look at IoT in the cloud, the advertisement is great. There's infinite compute and storage, and you can do machine learning and training, and there's all the tools are there for you to use. And you're in the cloud, you're not only connected to one device, you can connect to many devices. So you can merge and use the information from all those devices to come to a common solution, or get insights not only based on one device but on all devices. And that makes it possible to do remote monitoring, predictive maintenance, prescriptive maintenance. You can build digital twins on top of it for a really nice representation, live representation of what's going on in the world. But that's not the whole story. The IoT in the cloud is really great, but there are some cases where you would like to see some stuff happening on the edge. For example, if you want to make, if you get insights and you want to take some action on that. If data is first going into the cloud, the insights are generated, the actions are taken, and then the same path must be taken to send a response back to the device. That could take time. Or actually, what if the internet connection is broken at this moment? Like in the jungle of Malaysia, we had to rely on a really poor 4G communication connection, which was not always available. We had some days when it was actually raining a lot. It's the rainforest. We had to wait for one day until all the data, the connection was restored, and we got all the data from the device. On the other hand, there are also devices in the world which are not really capable to be connected to the cloud. For example, they are using protocols without security, which is fairly common in a factory because it's a closed environment. Nobody can get in. So why should we use security? Well, if you start to connect to the cloud, that's maybe not something that you want to connect. And what about privacy or IP protection? If you're taking images of elephants, for example, well, I don't think the elephant will be unhappy if his picture is seen on the internet. But if there are actually people in that picture, at that moment, at that location, a person is seen. So that's a GDPR violation. If you only take the picture locally, you process it locally, there is no actual information sent over that person to the cloud. For example, if you want to see how many people are walking by in a group, or you want to see if somebody is having a hard hat, a helmet, a security helmet, or safety goggles. Well, you don't have to know the person, the identity of the person. You only want to say, okay, this is not okay, so I show you a red light, or this is okay, I show you a green light. And last but not least, if you get a lot of data, you maybe want to transform it, you want to aggregate it, you want to filter it, maybe you want to save some costs and send less data to the cloud. Well, then you have to take some compute off the edge and use that for that purpose. So IT in the cloud and IT on the edge are complementary. And Microsoft is really offering a beautiful solution for that. All you need is an edge device that could be a Jetson Nano, like this one from NVIDIA. It has actually a graphic card installed, so you can make use of GPU. Or you use a device like this one, which is an actual industrial device, so there are no moving parts. It can also function when it's really hot. Those devices are both capable of doing Azure Iot Edge. Actually, the Raspberry Pi is also capable of doing Azure Iot Edge. So you can start with it at home. You just install Linux on it, Raspbian, if you're having a Raspberry Pi, or you're making use of Windows 10, the industrial version of it. That's the 1904 LTS version. And on top of that, you need a container solution. And for that, Microsoft offers Moby. Moby is actually an open source container solution. It's it's offered by Docker, and Docker is putting their logic on top of that open source container runtime. And you can install it on your edge device. And then you only need one more thing, and that's a IoT Edge runtime. And that's actually in Windows, a Windows service, or on Linux, it's a daemon. And that's the Azure IoT Edge runtime, which secures the device with the security credentials taken from the IoT Hub. And once you have a secure connection from the Azure IoT Edge runtime to the cloud, to the IoT Hub, you can start deploying containers using that Azure IoT Edge runtime. The security is, by the way, secured by either X509 certificates, or you can make use of a TPM, a Trusted Platform Module, which is a chip on the motherboard. It holds the identity of your device, and if somebody tries to steal that identity, they have to break open that chip, and well, that will ruin the chip and it will ruin your actual edge device, but at least your device is secure. The keys cannot be stolen. And it's also possible to make use of symmetric keys. That's great, simple for test and development. And last but not least, Azure IoT Edge also is capable to work in an offline scenario. So if the internet connection is not always available, it will still function. Your edge will run. It can do all the stuff that it's designed for. And if there are messages ready to be sent to the cloud, they will be stored on your device, on your hard disk, until the internet connection comes up, and the messages are sent to the cloud eventually. And Azure Iot Edge is open source. It's available on GitHub, and you can look at the code. And if you want, you can even try to make some pull requests. So how does that work with the containers? We have an Azure Iot Edge device to the left, a Raspberry Pi or a industrial device, and it has a connection to the Azure Iot Hub. Well, Microsoft provides a lot of services in the cloud, machine learning, cognitive services, SQL Server, and Microsoft also provides a Azure Iot Container Registry, which is a solution in Azure, a resource, and it can hold Docker containers. And Docker containers, well, see them as little applications with a manifest, with a batch file next to it, and say, if you want to run me, this is what you have to do. This is the recipe to start me. And those pieces of logic, those containers, they are sandboxed, so they cannot do more than they are told to do. And Microsoft makes use of that that container solution, that container logic, by offering containers, a lot of containers, like the stuff that they are running on Azure. There is a container which is offering Azure SQL Server. And they have a Azure Machine Learning container, and they have a Azure Functions container, and a Azure Stream Analytics container. You can run an Azure SQL Server container on Linux as a container. That's not something that I had in mind 10 years ago when I was thinking about Azure SQL Server. This is Microsoft, so it only runs on Windows. No, it also runs on Linux nowadays. So Microsoft provides those containers in a Azure Container Registry. And if I want to make use of these containers on my Edge device, I have to build a deployment manifest. And that's nothing more than just a JSON file which says, I want to run these containers, and these are the settings that I use, and make it so. And the Iot Edge device looks once in a while, it connects to the Azure Iot Hub, and it will try to get an updated deployment manifest. Keep in mind, it's an outbound connection. The Iot Edge device is in control. It will ask, and not all the way around. So there's no attack vector that somebody can try to send something to the Iot Edge device. No, the Iot Edge device takes the secure connection to the Azure Iot Hub, gets the deployment manifest, looks at the differences between the current one and the previous one, and it will reach out to all the Azure container registries where containers are to be taken from. And once the containers are there, they will start, they will work, and if there's no internet connection, they will keep on running. And the deployment manifest is not something really strange. Here's an example, a part of the Azure Iot deployment manifest. And as you can see, there are two containers shown. One is a container, and that's the topic of today, the Iot Edge beer lift. And there's also another container, and that's the heartbeat. And for example, the heartbeat gets an interval of 50 seconds. And the beer lift, because it wants to do something on the Raspberry Pi, it wants to make use of the GPIO, the input and output pins on top of it. It needs elevated privileges. So that's how a deployment manifest works. And of course, this is a nice story, but let's try to actually show how it's working with a demonstration. And I could have taken an industrial solution and show boring stuff about Modbus protocol, which is really great, but not for you. I was thinking, let's take something that's more in a real world problem that I have, because I have 3 grown-up sons and they are begging me for a beer lift. And this is a beer lift. It's a pipe in the ground. It's cooled. It's cool inside that pipe because it's in your garden. It could be a few meters deep, and if you pull it up, you get some beer bottles. But of course, I'm doing IoT, so I was thinking, okay, I want to automate a solution like that. I need something with motors. So I started to look at what my possibilities are, and I came up, okay, let's take a Raspberry Pi. I will write a Azure Iot Edge container, a custom container. And with that, I will try to figure out how many bottles are there. Are the bottles taken out? So I need switches if to see if a bottle is taken out, and I want to know the humidity and the temperature, and I want to know if it's if there's a leakage, if water is flowing in through because it's raining or not, and of course I want to control the motor, a motor, to pull all the bottles out of the ground and to take it down into the ground again. And once I have that I have to interact with it. So I looked at my options and I said, okay, Blazor, that's C# programming websites in C#. That's something that I'm willing to do. So I built a Blazor app on top of it. But yes, okay, this is the electronics. Let's start with the obvious part, and that's the bottle holders. So I have a son, and he's doing mechatronica, and he said, "Okay, Dad, let's do this together." So together with him, I built some prototypes, and this is a bottle like this one. And as you can see on the pictures, there's a switch inside, and there's a LED in it to show the position or to do something fun with it. And we did several versions of it. And in the end, we came up with a solution like this. I'm not sure if it's shown correctly, but the LED is hidden inside, and it will lit the label of the bottle when it's dark, so you can see what kind of beer you're pulling out of it. Well, once I had these figured out, let's do something with the switches and the LEDs. And then I was counting, okay, I want to do something with a reasonable amount of bottles. So let's start with 8 bottles. Okay, then I need 8 switches and 8 LEDs. So I had to do something with the Raspberry Pi because there are GPIO ports pins available, but my sons, they said, okay, 8 bottles, that's not enough. We want to go for 16 bottles. Why not? So I run out of the GPIO pins, so I had to come up with a IO extender. And as you can see, it explodes a little bit with the number of wires. on this breadboard, but at least I was able to read if switches were changing. You see on the right side that's one of the pins is taken out. So at least when we move over from 255 in binary code to one pin less, that's 127. So if I know about what's happening with the switches, well, then I have to also, I want to know if what is the position of the lift, if it's going up or it's going down, is it in what is the position? And I want to know if it's flooded, if there's something, if there's water detected at the bottom of the beer lift, I want to raise an alert. So with that, I did some further experimentation, and I added a relay so I can switch a motor on and off. I have the temperature sensor, that's the little white thing to the right. And I also added a sensor for humidity. So once I had this installed, I moved over and I said, okay, I have to give the container properties. I want to know the actual pin numbers that I need, the addresses for the I/O stuff. You have to configure it with certain addresses, and I want to do something with the interval. How fast am I checking for example, for the flooding? And once I know something about the device, I also want to do something with controlling it, moving it up, moving it down. I want to measure the temperature, and I want to advertise all the lights. So I came up with a solution like this. And here you can see the device which I built. That's my prototype. It's a, let me put the camera. Okay. I hope you are able to see this. Let me check this. Okay, a little bit more. Okay, yes. Okay, this is a breadboard. So there's lots of wires involved. And we have a Raspberry Pi. And I can play around with the switches. You see that I take out a pin. That's an equivalent of a switch, and a light goes on or off. That's, as you can see, if I touch the wrong wire, everything goes haywire. That's a breadboard, but at least I can do something with the pins. And I'm also capable to have some local logic. For example, if I make a shortcut on the flooding detection, you see all the LEDs going on and on. That is the flooding detection. How does it look in the device itself? This is on the screen a SSH connection to this device, and as you can see, every second I check all the switches, and I can also see if there's a flooding. So for now I'm simulating if there's water detected, and you can see that it's generating information. And the same goes when I change a switch. Let me put that in. As you can see, it says, okay, there's a change in the pins. So a bottle is taken out or put into the beer holder. So that's really nice information. And as you can see, we get information from the device sent to the cloud. And for example, here we see that there was a change in a certain slot of the device. I can try to make a change. Let me take out a pin, and yeah, as you can see now, there are two slots put on false. So I know in the cloud what is happening on this device. Let me do it again. I put in the pin, and again now there's only one slot put on false. Well, that's nice. So, what about how is that registered in the cloud? Well, the device is connected to an IoT hub, and an IoT hub in the Azure portal looks like this. There's a IoT hub for the beer lift, and as you can see, there are two devices connected. I have a daily quotum of 400,000 messages a day, and there is some activity over there. So let's look at the device itself, the registration of it. And if I go to the IoT hub section, and I go to the beer lift number 2, that's the prototype. We can see that there's a beer lift module running. That's this one, the BL, beer lift. And if I look at it, then we see that it is coming from a certain location. This is the actual container. And the container is, I went to Docker Hub. That's a container registry from Docker themselves. So as you can see, there are containers over there, and that's how you get a container. You can do it by hand with a Docker pull and then the name of the container, but I use Azure IoT Edge to pull the container from the cloud to the device. And let's look at the settings that I use for it. And as you can see, I have to give it a certain address for the I/O expander, and I have a certain interval on how long the motor must be running. There's no actual motor inside this, but at least I can switch the relays, which can be connected to a actual motor. So if I change these values, I can send them to the cloud. The Azure portal is a great way to look at the settings, but normally you do this by code. You write some script for that. But we are also it's also possible to send direct methods, and this is the fun part. For example, I can do a down to simulate, or actually give the command that I want to have the motor running and the beer lift is going down. And as you can see, there's a animation with the LEDs that it's going down, and it takes 10 seconds. And let's go up again, because when it's down in the ground, the LEDs are stopping. They don't have to lit when the device is in the ground. So let's go up again. And let's go the other side, all the way. And there is actually one empty spot, as you can see. So I can do some fun with that. I can ask the device, give me the empty spot that you have right now, the first empty spot. And as you can see, the LED starts to blink, and with a little bit of luck, I get a response back. It's a little bit small. Let's make that a little bit larger. Oh, too large. Slot 10 is at this moment empty. And I can also mark the position of that. So I can give a command to a person standing nearby from, okay, let's do something with position 2, because the beer lift in the end will be connected to my application on my phone or with the application on the website. So as you can see, position 2 is now blinking, another LED. And I even went for circus, just to have fun. And as you can see, everything starts to run. So there are direct methods sent directly to the device. If the device is not connected, the direct methods will not work. This is a live communication between the cloud and the device. Well, okay, this is great. I know it works. I had my device. Now it's time to take it a little one step further. So I went to the a second-hand store for electrical stuff, and I bought myself a electrical motor, and this thing was working on 340 volts. Oops, that's a little bit too heavy, but my son had a great idea, the one with the mechatronica education. He said, Dad, I will fix this for you. So he came with actual relays, and now I'm capable of switching 340 volts with a Raspberry Pi with some relays in between. And the breadboard, I started soldering and thinking about, okay, how can I put that breadboard into a actual stuff that is a little bit more rigidized. So well, you see the result. This is a kind of a stackable solution. So all the pins are connected to solution where I can put a wire in and I can switch it. So there's one layer for the relays, there's one layer for the I/O expanders, there's one layer for the temperature and humidity and the flooding detection. Well, this is what I can do. And it works, and it is well, you can shake it and it will still work. So I'm happy with that. And then it was time to put it all together. So I bought iron, I bought wires, I used a lot of tie wraps, and in the end I had a solution with the motor and the electronics underneath the bottle holders. And this is the actual result. Move the camera. That's the interesting part with IoT. There's a big device next to me, and if I let me change the camera, because here it is. I made a device. It's on camera, that black box, And with the device, I'm capable of holding a lot of beer bottles, and I built myself a C# application, a Blazor app. It's all written in C#, and I'm capable of controlling this device. So let's do that. So let's try to figure out. Let me check one thing more. Yes, there is a application somewhere. Here it is. This is the beer lift application, and well, the screen is little. It's big. It also works on a telephone, and then the bottle holders line is just one selection. But as you can see, there are some buttons. There is a selection list and some other stuff. And let's try to move the beer holder up. Ta-da! It takes a minute, by the way. And well, it starts to move. And there the bottles are appearing, and as you can see also the lights, they are turning around, as with the red lights which we have seen. And it's a prototype, so it's not that stable, but at least it's functioning. And the lights are running. I can actually try to highlight a certain bottle. Hey, this is a nice bottle. I want to have a La Trappe double, so I take it out. The light starts to shine. That it's capable for a new bottle to add, and I can put it back, and it's occupied again. I can take it out, and then I say, let's advertise, because it's night. Let's advertise all labels, so I can look around and see what's happening. I can say, okay, I want to play a joke with a friend. I can actually do a roulette, and well, if I put a bottle of water in between, then maybe I'm in luck. I have the one with the beer, and he has the one with the bottle of water. And I'm also capable of adding a new bottle. For example, if I have a known, I can say, okay, I want to add it. Give me the first spot, and then I put it in, and it is detected that it is placed, and now it's occupied at that name. So it's good enough for me, and it's a nice solution. I cannot demonstrate it here, but if there's also a leakage detection, so I will get a message here if something happens, which if there's water detected. But that was not good enough for me. So in the whole solution that I used to get this running, I also added a logic app. And the logic app, let me try to figure out. Because I get the message from the devices when there's a leakage, and those messages are taken up, are all sent to a Azure Stream Analytics job. And this filters in the cloud for me if there's a flooding detected. And those messages are sent to a logic app. And if I look at the history, as you can see, a few minutes ago, that was when I did a shortcut on the I short wired the leakage detector on the breadboard. Then a message was sent. So we have a full solution from edge device, message sent to the IoT Hub, through Stream Analytics, towards logic apps, and all the messages which are sent are also sent to a web application, and live the messages are coming in using SignalR. So this is a fun project. I still have to dig a hole in my garden to get this device into the garden. And this is just for 8 bottles, so I'm planning to build a bigger one, bigger, better, newer, with 16 bottles. Well, we've seen actually just 2 solutions of the whole IoT stack that Microsoft is providing. There are so much services that we can use. At this moment, we only have seen Azure Iot Hub and Azure Iot Edge. If you want to do something yourselves, well, there are a lot of places that you can go to. My favorite is the Azure Learn. There are beautiful trainings about stuff in Azure and also Azure Iot Edge. I have a blog, and all the code that you've seen is available on GitHub. Okay, thank you.
Thank you, Sumner.
Wow. Yeah.
What a brilliant product. Yeah, I wanted to ask, are you aware of the fact that we are still looking at your beer bottles? Yeah.
Yeah, you're making me thirsty.
Yeah. I have one question. What is this sign for a beer lift?
Awesome.
Is that a new hand sign? A new sign, or okay? Yes, this is a project which is really good, recognizable, and it shows all the capability of Azure Iot Edge.
Yeah, really great, and also awesome that you've shown or told us that Microsoft Learn is a great resource to get started with these IoT projects. For the sake of time, we can't go into any more questions because we really need to end this. But thank you very much. And after this presentation, I think that you have deserved a Tessels triple at least. Definitely. Yeah, no double, just take the triple one immediately. Yeah. So thank you very much, and thank you all for watching. I want to thank my co-host Esther for starting this stream alone, completely by herself. She did a great job. And I also want to thank I also want to thank our sign language interpreters again as well. Thank you very much. And we will see you next time, next month, the first Thursday again. Thank you. Bye-bye.
Bye.